Our next guest, Professor, I guess we all know you, Professor Arlindo Oliveira, the author of a book, Digital Minds. I would rebaptize the book as Brilliant Minds, and I would, point you out as a brilliant mind, someone that has been doing so much in these fields. Artificial Intelligence, Applications, Implications, and Speculations. That's the title of your presentation. Thank you so much for joining us.
In Portuguese or English? English.
English, please.
Okay. Well, good morning, everyone. It's a pleasure to be here. Thank you for the invitation. I was wondering what to talk about because I do a lot of talks about what is AI in general for non-specialist audiences. And I know many people here are actually specialists, so what could I possibly tell them about that they don't know? And I didn't really figure anything out, so I'll just try to wing something. But at least I'm happy that, hold on, how does it move? I'm happy that I did not decide to talk about computer creativity, because the previous speaker just spoke about this. And of course, you know, this very famous painter Van Gogh, and this duplicate. Anyway, so I'll just try to wing a few things here and try to give you an idea of a more global view on artificial intelligence, and of course focus on the impact it has on analytics and on data analysis. But first of all, I'd like to say that I will be making a few predictions, and making predictions is always very difficult, especially about the future. This is a saying that originated somewhere in Denmark in the early 20th century. It's much easier to make predictions about the past, but the number of predictions that were wrong is in science and technology is amazing. And you know many of them, but I have my own favorite. This is the great crisis of the late 19th century. It was called the Great Manure Crisis of 1894, and at the time there was a huge environmental problem. The huge environmental problem of the end of the 19th century was that transportation was done by horses. There were 50,000 horses in London, 100,000 horses in New York, and the problem was the manure, right? And if you've seen a horse in a park or so, you can see that just a couple of horses can create a lot of manure. Imagine tens of thousands of horses, and nobody could figure out how to remove the manure from the streets at the right speed and amount. And the projection was that London and New York and other big cities would be covered in manure in just a couple of decades, and it would be the demise of these cities. They even convened a conference to address this problem in New York. It was to be an 8-day conference, and after 3 days they gave up and they closed up the conference because no one could come up with a solution to the problem. It was simply a problem that technology, the science of the day, could not address. And as it turns out, the internal combustion engine appeared. These cities did not become covered in manure, and this environmental problem did go away. I'm not suggesting that the problems we have today will go away in the same way, but to be fair, we have the technology to make them go away. We just need to have the right incentives. We just need to, as a society, make the right decisions and make the big environmental problems of today go away. Okay, this is in part due to what is known as Amara's law. So Amara's law is basically an empirical statement that says something like, in general, we tend to overestimate the effect of a technology in the short run, but to underestimate this effect in the long run. And this has to do with the ever-accelerating pace of technological development, with the exponential pace of technological development. For instance, imagine some technology that develops, I'm having problems here with the clicker, that develops in this exponential way. So the blue line is the true development, the true speed of development of some technology, and the red line is some sort of linear extrapolation we do about this. And if you imagine in 10 years the technology will be here, right? If we imagine in 10 years the technology will be here, then we sort of are a bit optimistic in the short run. Maybe we expect too much in just a few years. Maybe we are right in about 10 years. But what we don't we cannot appreciate is the technology will keep developing in this way. And in 20 years, now whatever optimism we had there, now it's actually very pessimistic. And if we do this in 40 years in the future, this cannot even be really called an estimate. It's just a totally wrong guess. Okay? And this happens with many technologies that have exponential developments, and a lot of technologies do have this type of developments because they build on previous things. Okay? Of course, digital technology is the one that we are more familiar with, is the one that has had this clearly exponential development over many decades. I guess you are all familiar with Moore's law, the empirical statement that the number of transistors that you can put on a chip of a given size doubles every 2 years. This doesn't sound too bad, except that that's been happening for more than 4 decades. And if you double everything every 2 years and you keep doubling and doubling and doubling every 2 years, what happens is that this thing will exceed any expectations you might have. For instance, if you see what you can see here is the number of transistors that were manufactured on planet Earth up to some point, up to 2000. So we have something there on the order of 1 trillion, 1.5 trillion transistors. That was the total number of transistors that existed on Earth up to 2000. And if you look there, you can see that fairly rapid rise around 2000. And you think a little bit, yeah, that makes sense because, well, the internet basically exploded there. We started using browsers. Google appeared there. We started sending emails back and forth. So that makes sense. That is a big explosion there. But if I plot the same curve, exactly the same curve, I just changed the scales. I'll go 10 years further. And now the vertical scale, notice we are not talking about trillions. We are talking about a quadrillion now, right? About a quadrillion transistors. And now, nothing much happened around 2000, right? It was very calm over there. The explosion took place around 2010, and that also makes sense, because that's when we started having smartphones. Everybody started carrying basically a supercomputer in his or her pocket, and you have a machine with 1 billion transistors on your pocket. I don't know if you have an idea, but if this thing, just the CPU, but if this thing was made with valves, the technology that was used to make the first computers in the 50s and in the early 60s, if this machine was made with valves, it will take the space of a big soccer stadium, like the Benfica Stadium or Sporting Stadium. So this is the amount of technological evolution that we had in just a little bit more than 4 decades. But if I go forward in this series, this is what happens. Actually, nothing much happened in 2010. Surprisingly enough, the number of transistors on planet Earth keeps growing up exponentially, and this now, I forget what exactly the English unit for this, but it's something like the whatever. So this is typical of exponential growth. You are always at the moment of the explosion. However fast it looked in the past, now things are evolving faster. Okay? And if I project 10 years further, you can already imagine what happens. We will look at these particular years today as years where nothing much happened, where very calm, technology was developing slowly, and we could track and follow all the developments. Of course, to be fair, exponential developments do not last forever. Nothing that grows exponentially can last forever, if nothing else because of the laws of physics, because there are not enough atoms on the universe to sustain an exponential growth forever. This is also true to the economy, by the way. We are all very used of the economy growing at whatever, 1, 2, 3%. We want it to go forever, but no matter how many improvements we make on it, it will not go forever, because nothing can go forever exponentially. But this still does not mean that it will not go forever for decades or for whatever period of time. We keep changing the technology, we keep changing the things we can create, we keep changing the things we give value to. So it may go for exponentially for still a long time. And this leads to my conclusion about this part, which is we must be ready for an ever accelerating technological world. Right? And this means that we, at least for some more time in what regards digital technology, the next decades, in my view, we will see an accelerating development of technology. Some people do not believe in this. Some people believe that everything interesting in technological development that happened during the Industrial Revolution and the early 20th century. We discovered the laws of physics. As far as we know, new laws of physics will not be discovered in the next decades or so. At least I'm quite sure that no revolutionary new discoveries with practical impact will happen in the laws of physics. We may discover new particles, maybe we'll discover something new about black holes and strange particle interactions, but it's very, very unlikely that that will create radical developments in practical things. But what we already know is enough to create radical developments in practical things for many decades to come. Nanotechnology will have a huge impact. You heard about it, the previous speaker talked about. Biotechnology will have a radical development in the next decades. And of course, digital technology will keep changing the world at an ever-increasing pace. So, but I was supposed to talk about AI. Well, AI is the result of an old result, a result that has almost a century now, a little bit less than a century. And this idea that was reached by Turing and Church, that if a computer is powerful enough, then it is universal. And universal means that any universal machine is equivalent to another universal machine. This is called Turing universality. And you don't need to be very powerful to be universal. Any laptop that you have is universal. Actually, things much simpler than a laptop are universal, are as powerful as universal Turing machines. There are a few mathematical details here that I'll skip, but this is the basic idea. And as far as we know, the brain is also Turing universal. The brain is also equivalent to a universal Turing machine. And if this is true, and is very likely to be true, as far as I know it is true, then whatever you can do with the brain, you can also do with the machine. The opposite is also true, but we are not interested in that, right? We are not interested in using brains to emulate machines. It's expensive, it's boring, and so on. As far as we know, whatever you can do with the brain, you can do with the machine. And that means that if the brain leads to intelligence in us, then you can also create intelligent machines. It goes further. If it is the brain and the nervous system that creates emotions in us, then you can do it on a machine. If it creates creativity in us, then you can do it in a machine. It's much deeper. People used to say, oh yeah, they can be intelligent, but they'll never be creative, they'll never fall in love, they will never... There is a mathematical result that says it is possible that they will. It is at least conceptually possible. Whether we can or not write those programs is another issue. But conceptually, at least, that is possible. And of course, I don't have much time. This counter is for real, or I have a few minutes more, you know, whatever. Okay, so there are different ways to go about AI, right? I don't have time to go about the bio-inspired AI. This is too short a talk, so I'll just go about the synthetic, which I also think is more applied, is more closer to what you know and you want to know. What is really AI these days? Well, this is my young classification. I'm somewhat fond of it. I think it makes some sense. AI is many things. Okay, hold on. You are still not seeing it. AI is many things. But it includes a number of technologies. Knowledge representation, search and optimization, lots of stuff. People have been working on this for decades. But it includes the critical technology, which is machine learning. Okay? I will let you know, and you already know, but I will just spend a minute on that. But this has many, many applications. So a big group of applications is this one, is data analysis, analytics. You already heard about it, you work on this, you know what this is. It can be used for almost anything. It can be used to sell you stuff that you didn't know you wanted, based on the data that you have given before. It can be used to optimize processes. The so-called Industry 4.0 is mostly process and logistics optimization. It can be used to create new scientific results. It can be used to manipulate elections, which is just selling a product like any other. And it can be used, of course, for financial analysis and financial profit. Those are applications that do not replace human beings. Mostly they do not replace human beings, right? Before Facebook ran their analysis on the feeds of everyone. There was not a person there running that analysis that gained money to do that, right? This is new applications, new economic value created. Now, there is also the idea that you can use AI to replace existing jobs. And you've heard about this in the talk before, you've heard it many times. This is, in fact, it starts to become possible. Many jobs are relatively repetitive, are relatively boring. And there is this general rule, the more boring your job is, the more likely it is to be replaced. Because if it's boring, it's repetitive. If it's repetitive, you can learn to do it basically by looking at the way it was done in the past. That's why taxi drivers and probably junior legal analysts and radiologists, because you may be highly qualified to be, you may need to be highly qualified to be a radiologist, but the fact is that you spend your day doing the same thing every day, looking at an image and deciding what's in there. And if your job is highly repetitive, it's very likely to be automated. And this is, of course, there are a number of professions there. You've seen many more. But there is a third area. And this is the area that we spend probably more philosophical, more interesting from an ethical point of view, more challenging from a scientific point of view, is the idea of artificial general intelligence. Is the idea that if you just get the right algorithms, if you just find the right method, if you just have the right CPU and the right computer support, then maybe you can recreate intelligence that is as flexible, as powerful, as multi-domain as ours. To be fair, we do not know how to do this. We have no idea how to do this. Nobody knows. Not the guys in DeepMind, not the guys at Google, not the guys at Amazon, and nowhere. Right? But it is possible in principle. So it may be possible. We may be able to do it. You may say, and some people say, it's too hard, we'll never do it. Maybe. I actually don't believe, but of course the jury is still out. And this is not like going to Mars, right? We know how to go to Mars. It's very difficult. You need a very big rocket, an FBR. You need a very big rocket. You need supplies. You need a lot of stuff. But we know how to go to Mars. We know what it takes to go to Mars. Maybe it takes 1 or 2 or 3 decades to go to Mars, we don't know. But with strong AI, with AGI, artificial general intelligence, we don't know what it takes, because we don't know enough about the way the brain works. But that is not the same thing as saying it is impossible. And now I have to speed up. Of course, all this idea of data analytics is that the better you know a customer, the better you can sell him stuff, but also support him and keep the customer. As I said, machine learning is the technology at the core of all of this. Is this idea that you can learn from data. You can classify machine learning in 3 big areas: supervised learning, unsupervised learning, and reinforcement learning, which is a sort of semi-supervised learning. I don't have time to go into detail, but let me just give you the critical idea of what machine learning is. Instead, if you need some specific application, you need to write a program to do it. The program was written by a programmer. It runs on some input. It generates the output. This is the basic idea. Computers work like this. We all know computers work like this. The problem is that some computers are very hard to write. The program to look at the radiography and generate the output, to look at the resonance and generate a diagnostic, is almost impossible to write. But it can be learned. It can be learned with machine learning. It can be learned if you just give enough examples of input-output, and then it generates a program. That is why machine learning is changing the paradigm. You don't need to write the programs anymore. You just need to write one very, very good program, the one that is here. And then it can, at least in principle, learn to do anything. This is why machine learning is a revolutionary technology. This is what makes AI a general purpose technology, like electricity, right? When electricity was invented, people didn't know it was going to be everywhere. They just thought it might be good to light up the room, right? But AI, machine learning, is also a general purpose technology. It will be everywhere. because it can do anything. It can learn to do anything. Now, this is the point where I have to make a difficult decision. So, the reinforcement learning is a different part, mostly used in sequential tasks. And there's, of course, this idea that you can even learn if you don't have a teacher. You can just look at the data. This is unsupervised learning, and you can do clustering and all sorts of analysis. There are many ways to do learning. Pedro Domingos has a very nice book on this. He breaks with some creativity the methods in these 5 families: the connectionists, the symbolists, the statistical, the genetic, and the analogizers that look for analogies. I recommend the book. I don't have time to go about this. The fact is that these days, a large part of the revolution is being created by the connectionists because they can address problems that were impossible to address until now. But they are not the only tool. There are many tools here. There are decision trees, there are decision forests, there are all sorts of machine learning techniques that can be used, some of them better for some problems, some of them better for other problems. And I will not go into details how neural nets work. They are simplified models of neurons in the brain. You put them together and you program them by basically setting up the weights that connect these simple units. And what happens now is that, let me skip this and this. And the short movie which I'll skip. What happens now is that you have pre-made architectures that you can download from the web, pre-trained, and you can solve in a day problems that a PhD student will not have been able to solve in 5 years. Only 10 years ago. So you can download these predefined, preloaded, highly sophisticated architectures that can recognize faces in an audience, maybe drive a car or do whatever. And the applications are many. You've seen several of them: self-driving cars, synthetic personas, synthetic photos and videos, systems. We can maybe turn off the sound here. And one of the most impressive results, which is a system that learned by itself to play the game of Go, a game that was believed to be immune to AI because the traditional branch and bound search methods would not work in this. Given all this, do deep neural networks understand what they see? Are they some sort of the premonition, the embryon of a general intelligence? Unlikely. For instance, this is things that were classified as dogs by a system, a convolutional neural network, and you can see very well that some of them are dogs and some of them are not. And this is what happens because these systems look at statistics. These systems don't understand the world with the depth that we understand. We can tell that some of these things are not dogs, and certainly here we can see that some of these things are edible and others are not. Okay? There are a number of interesting questions about this, mostly related, as I said, to artificial general intelligence. There is this idea that we may be in the brink of a singularity where the intelligence will take off by itself. Maybe it's possible, maybe not. We don't know whether an intelligence explosion will happen. It is possible in principle, I'm quite sure. Whether it will happen or not, I think it's somewhat unlikely. I think we'll be able to keep tracking of what's happening and controlling these systems. But we must be ready to share the economy and the society with other intelligent agents. I think this is, if you don't remember anything else from my talk, which is very light, remember that we have to be ready to admit in our society other agents that are not humans. As we now admit animals, as we now admit other things, so being the only intelligent species on the planet is actually a relatively new thing. Only 12,000 years ago there were 2 intelligent species on the planet, and there were more in the past. This is a relatively new thing. And I will terminate, if this works, with a video.
Few outspoken intellectuals such as Elon Musk, Sam Harris, Stephen Hawking, Nick Bostrom, to name a few, have voiced genuine concerns for the rise of artificial intelligence, as brilliant minds across the globe are competing to retrace the hundreds of millions of years of evolution that resulted in the human brain. And while many experts have no doubts about machines' ability to achieve human-level intelligence at some point in the future, just as many believe it to be an impossibility. And perhaps it is. Perhaps we are incomprehensibly complex in such a way that we cannot do what nature has done to us. Then again, if random mutations can lead to intelligence, how hard can it be?
Okay, and if you want to know more about this, there are a number of fascinating books. Use the time while there are still books. That one about this idea of a super intelligence that may appear, singularity, impacts on the economy and on the job market. A very interesting and funny book about transhumanism, this idea that will transcend our biological support and sometime in the future live in some other support. That book by Pedro Domingos on machine learning. This one on this idea of the intelligence explosion by Max Tegmark, and two books of mine. This one also exists in Portuguese, and this one is only in Portuguese by Foundation Francisco Manuel dos Santos. Thank you very much. I apologize for the extra time.
Muito obrigado. Professor Arlindo Oliveira, what a privilege. Thank you so much for a world-class, free world-class for all of us. Before we go and eat some of those dogs we saw, because some are edible, I just want to say I think the 20 minutes delay we have were totally worth. I mean, we had Sandra with us, amazing presentation, Diego, Rui, Steven and Arlindo Oliveira, what an end to it. Thank you so much for putting up with the delay. Let's go and have a coffee now, and we should be back in some 15 minutes. Thank you.